Okay. So sequences and series. Okay. So first is sequences. So sequences means what? So like A1, A2, A3, and so on. These are the terms, and up to infinitely many. Okay. This is called a sequence, and we represent it like this. A. Okay. Like as for example, like 1 upon n. So you write like the terms of the sequence like 1, 1 by 2, 1 by 3, and so on. Okay, like n. So the terms of the sequence like 1, 2, 3, and so on. Okay, so these are the kind of sequences. So this is general. So when you take the limit of that sequence an, and if you find that limit as suppose say L, uh, if you find the limit L, okay, then you can say that the convergent, convergent sequence. Okay, so that is called the convergent sequence. And like this, limit n tends to infinity, 1 upon n, you know, that is nothing but 0. As you go on, go on, go on, it will converge to some number. Okay, like decreasing, decreasing, like here say 1, then 1 by 2, then 1 by 3, then 1 by 4. So all the terms going towards 0. So that is called the convergent sequence. And if this limit does not exist, like in this limit does not exist, 1, 2, 3, and so on, go on. So if the limit does not exist, then that kind of sequence is known as divergent. Okay, that kind of sequence is divergent sequence. Okay. So that is about the sequence. But normally, our mission means you can say like in exam starts from series. And so what is the series? Okay, what is the series? So this is a sequence. Okay, like A1, A2, A3, and so on. These are all sequence terms. If we add all these terms like this, infinitely many terms, then that becomes the series. That is called the series. So this is a sequence. While this one is called series n equal to 1 to infinity an. This is called a infinite series. This is called infinite series. Okay. So here we ask a question that we have infinitely many terms and we are adding whether the sum exists or not. Okay, that is a question. Now, if the sum exists, then we say that it is a convergent series. And if the sum does not exist, then we say that it is a divergent series. So the beauty is like you are adding infinitely many terms and you are dare to ask the question whether the sum exists or not. Because infinitely many terms we are adding. It requires infinitely many time. But in a finitely many time, we are asking a question that whether the sum exists or not. If the sum exists, we call it is convergent series. If the sum does not exist, we call it is a divergent series. Okay. Now we have the certain kind of series is. The one of them is geometric series. Why this we are taking first? Because you have already studied the geometric series in your 11, 12 standard up to finite many terms. Okay. So how the geometric series looks? So it looks like this: A plus AR plus AR square and so on. Okay. We can write like this: series n equal to 1 to infinity A r power n minus 1. Or you can also write the same thing as series n equal to 0 to infinity A r power n. Okay. Either you write this way or this way. Now just observe here. Each term, like first term is A, second term is AR. So if you divide the first term by like second term like this, so you will have R. Say third term with the second term, again you will get R and so on. So that means this is a common ratio. That R is called a common ratio. And A is called the first term. A is called the first term, R is called a common ratio. Like 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 and so on. This is a geometric series where A is the first term is the 1, but common ratio is 1 by 2. Here A is 1 and common ratio is 1 by 2. Okay, you divide the previous, means like third term 1 by 4 divide by with 1 by 2, you will get 1 by 2. 1 by 8 divided by 1 by 4, 1 by 2. 1 by 16 divided by 1 by 8, 1 by 2 and so on. Okay. So this kind of series is known as a geometric series. And there is one theorem, it says like this: if modulus R is less than 1, that means if the ratio, common ratio is in between -1 to 1, okay, then series, geometric series is convergent. That means you can find the sum of that series. And exactly sum also you can find, and that sum is first term A upon 1 minus the ratio. That is the theorem. Okay. So by using this, we can have some example like, so that means if modulus R is greater than or equal to 1, then that series is divergent. Okay. So let us have, say, one example like 1 plus 2 by 3 plus 4 by 9, say plus 8 by 27, plus say 16 by 81, and so on. Check for convergence, and if it is convergent, then find the sum. That is a question. Okay. Like check for convergence and find sum if convergent. Okay. So here the first, this is first of all you need to check uh, whether this series is which kind of series. Okay. So every term you see 2 by 3, 4 by 9. So if you divide, you will get that. Can you write like this? Like this. So that's, you can understand that it is a geometric series. Okay. This is nothing but a geometric series. What is the first term? 1. And what is R? 2 by 3. And does 2 by 3 lying in the interval -1 to 1? Answer is yes. Open interval 1 to 1, less than 1. Okay. So that means given series is convergent. And you can find exact sum also. What is the sum? A upon 1 minus r. So A is the 1, first term. 1 minus r is 2 by 3. So this is 3 minus 2, 1 and 3. So exact sum of this series, you have infinitely many term, but its exact sum, you have infinitely many term, but its exact sum is 3. Okay, so that is one example. You can have one more example like this, like series n equal to 0 to infinity 8 power 2 by n 8 power 2 by n over 3 power 3 by 3 power 3, 8 power 2n over 3 power 3n. Okay, this is one series. And you need to check whether it is convergent or divergent. Okay, so if you take n equal to, okay, first of all, let us write in this way. Series n equal to 0 to infinity, we can write in this way 8 power 2, so that is 16, 3 power 3, that is 27, and power n. Okay, so n is equal to 0. So if you take this is geometric series. This is geometric series. What is first term? 1. And what is the ratio? 16 by 27. Okay. You have any series like n equal to 0 to infinity, a r power n. A is first term, r is the common ratio. So a is 1 and r is 16 by 27, which is less than 1. And therefore, given series is convergent. And since it is convergent, geometric series, you can have sum is a upon 1 minus r. First term is 1. 1 minus r is 16 by 27. So you can have like this 27 minus 16. What is 27 minus 16? 9. 11. Okay. So 11. So this is the answer. 27 upon 11 is the exact sum of these. મેં ભૂલ કરીને 16. Okay, ના correct છે. ભૂલ કરી છે. So let us change this. Instead of 8 power to n, let us write 4 power to n. Okay, because 4 square is 16. And okay, so that is now it is correct.